Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. I'm sorry that we're running a few minutes late because even though I have all these great internet-connected clocks around, I was paying attention to this wristwatch that is about 3 or 4 minutes late. So I'm taking that off. I guess I could just set it. Here, let's set it. What's the time? 1:04. Sorry about that. Yeah, just a few minutes ago, I was like, oh, good, I have 5 minutes. And then I noticed that was a lie. Here we go. We're almost there. How you all doing? Thanks so much for stopping by. I've been out of town on and off for a couple weeks, and it's good to be back. I wasn't out the whole time, but a couple days here and there on Thursdays happened. And I'm excited to be back and with a project, a pretty relevant project. You probably saw me tease it the other day, yesterday, and they showed it on Ask an Engineer. It is a Raspberry Pi in-stock alert device. I don't have an exact snappy name for it yet, but I'll show you that. You can build one yourself, and then you will get a really timely alert when Adafruit has Raspberry Pi boards in stock, and you can go and buy one real quick if you've been looking. This piggybacks off of the rpilocator.com, so thank you so much to the creator of that. We'll take a look at that. We'll look at some details. Let's see. In the meantime, I'll say, if you're wondering where the chat is, this is our Discord chat right over here at adafru.it/Discord. You could head over to the live broadcast chat channel. In fact, let me widen the crop there on that. You can see all those channels right there. So we've got live broadcast chat. There's a live broadcast announce channel, as well as, if I scroll over here, you'll see many other, oh, hold on, let me make that big for you. There you go. Many other channels where people are chatting all the time. I think we have over 30,000. Did we hit 35,000 members? Something like that. It's a nice, healthy Discord. So head on over there if you want to see what's going on. Let's see, what else? We've got a job board. If you're looking for work, you could head over to jobs.adafruit.com. It looks just like that right there. And you can see there's some cool gigs here, freelance gigs, full-time, freelance, full-time, contract, remote. This is the newest one that I've seen. It's a basic 3D modeling skills required. Someone to create some chemical model STL files for I don't know who's using it or for what, the Freed Radical Labs, but looks interesting. So if you are a 3D modeler, looks like it's to possibly be used for 3D printing if they're looking for STL files. That's just one of the many jobs that are posted right there on jobs.adafruit.com, so go check those out. All right, what else? I am also keeping an eye on the YouTube chat, so hello. Hey, Paul Curry, Charles Brenniford, Leonard, nice to see you all. And if we have people, like I said, over in Twitch or Facebook or other places wondering where the chat is happening, I can't keep an eye on all of those, but I am keeping an eye on our Discord. So head on over there, and you can also get questions answered or participate in the fun. Let's see, next thing I'll mention is I have a show on Tuesdays. That's it right there. It's JP's product pick of the week. Right off camera, I have my pegboard full of cool gizmos, and that's because on the product pick show, oops, hold on, got to do some real-time editing. I forgot to swap those out. That was not this week's. That was a while ago's. Here, let's swap that layer out real quick. You can see this in real time here as I fix my setup. I'm going to blame my watch again. It's probably the watch. So here we go. That was the recap right there. That was this week's product pick of the week, is the ESP32S2 TFT Feather. Bear with me because I'm going to remove the there it is. Yes, that's 1 whole meter of it. Mute that thing. Our alligator clip NeoPixel strips, and we have 2 versions of them. You can see. And let me add in the proper one. Let's go get a video file for you. Here. The Feather ESP32S2 TFT. This is a fantastic board. It's kind of one of the most modern Feathers that we have, since it has Usbc on it, which I love. It has a Stemma QT port on it, so you can just plug a sensor or something into that. Just plug that right into the top there. On the back side, you see we've got the big ESP32 S2 package on there, as well as most of the rest of the charging circuit and passives and voltage regulator and so on. This can plug into a breadboard. This can have things plugged into it. It can go into a doubler, into a tripler. You can solder things directly to it. So you've also got mounting holes on there. So you can really use this like you use any feather. But the fact that you've got this great looking, sharp, colorful display on there allows you to get a lot of projects done really, really easily. That's my product pick of the week. It is the Feather ESP32S2 TFT. All right. Oh, sorry, you may have had an echo. I don't know if I pulled the mic off there. Got technical issues going on. Yeah, I had an echo. Sorry about that. I left the mic running. The My Watch is the new Lars. That's the new thing we blame, according to Andy Calloway. I like it. Toddbot's suggestion over here in our Discord, by the way, if you're wondering what kind of fun we're having over here in Discord, Toddbot says I should do a live stream where I stream all my previous live streams simultaneously. I should show you sometime. Speaking of that, I have this PDF file that I use to make these thumbnails, and I just hide layers on it, and I've done, I think that was the 81st episode of that show, so I have about 80-some layers of different headshots, different product shots, different text, and the rendering engine for the Finder on Mac OS doesn't know about Photoshop layer hiding, and so I think it's actually when Photoshop generates the thumbnail, it just shows all layers, so it looks like a laptop that has been sticker bombed or a skateboard that's been covered in stickers. It's wild. Okay, let's see what else is going on here. Let's dive into the wonderful world of CircuitPython with a little CircuitPython parsec. All right. For the CircuitPython parsec today, I wanted to show you how simple it is to use a mouse cursor in CircuitPython, particularly on the PyGamer or PyBadge. This can be generalized for other boards, but it's really, really almost plug and play with these two boards to use the Adafruit cursor control library. So you can see here I have a PyGamer, and I'm going to move the joystick around, and you'll see I get this nice, smooth cursor action. There's a little bit of streaking, I think, on the video playback, but in real life it's really smooth, really nice. And you can see here, this is probably slowing it down a little bit, but just so I can have some output that could be useful, I am printing in my serial output here the cursor position on X, Y. If I go ahead and resave that with that commented out, now it's probably going to run even a little smoother. You can also see here I'm doing things like click. When I click a button, I get a little update about clicking. And the way this is set up is really easy. First thing I'm going to do is import the cursor control and the cursor control cursor manager, set up the board, put the mouse cursor onto the display using display IO, and then during the main loop, all I do is cursor update. So internally, the library checks to see if it's a PyGamer or a PyBadge, and it automatically hooks up the XY of the joystick or of the D-pad buttons to the XY of the mouse. Now, you can do things like change the speed of it, change the size of it with additional controls, but the most basic usage of it is this really nice, easy cursor that you can then use to build other applications on top of. And we have some great examples of both this simple setup as well as clicking some buttons and having things change as you click the buttons. And so that is how simple it is to set up a cursor on a PyGamer or a PyBadge inside of CircuitPython using the cursor control library. That is your CircuitPython parsec. Wow, wow, wow. Wow, wow, wow. CircuitPython All right. So let's see. What have we got next? I think I wanted to dive into this week's project. So first, let's do a little bit of an explainer. Let me go to the browser here, and first of all, what's the issue here? The issue is if you head to Adafruit or pretty much anywhere else, and look for a Raspberry Pi board. What you're going to see is out of stock. So we have a bunch of them that we carry normally, but they've been constrained by parts shortages, and they've been coming out in small batches. So we usually release about 100 at a time when we get them in, and they sell out really quickly. Now, we've been doing things to prevent single individuals from hoarding them and reselling them. We really want to get individual boards to people who want to use them for projects. So we have some things going on with our logins and two-factor identification and checking to see that people aren't using just slight variations on the same address and so on. But separate of that is just the issue of finding out when you can go and try to buy one. So the board right here I've got, this is a Raspberry Pi B Plus, I think. I forget which revision that is, 1.2. These are normally $35, but you're seeing people trying to flip them for $100, $200 online. You don't want to do that. You want to get one when you can get one. We had some in stock yesterday. The Pi 4s came in stock very briefly. They sell out pretty quickly, and we think largely to honest customers who just want to get a board. But one way that you can find out when they are in stock, besides using the typical email alerts from Adafruit, is using our Pi locator. Our Pi locator. So our Pi locator, you can see here, this has some great sorting for, hey, let's only check people who have it in stock. We can do by vendor, so alphabetically, Adafruit comes up at the top here. And you can see right now, none of the ones that Adafruit lists are currently in stock. But this site is polling all of these different places pretty frequently. I'm not sure what the cadence is of it. And then it automatically tweets when it sees something come in stock. So Liz, Blitz City DIY, wrote some code for a previous project that would do something when a certain tweet came out on a certain account, or a certain word went by on a certain account. And so she was able to update that and add some bells and whistles so that we can do the same thing, but now for Adafruit having stock coming from this Twitter account from our Pi locator. So if we click on their little Twitter link there, you'll see here are typical tweets that go out. And so 4 hours ago, Adafruit had some of the our Pi 4 Model B, 2 gig of RAM. It said 1 unit in stock, but earlier it said 100 plus, so that was probably just over the course of that edge of a change. So earlier today, 4 hours ago, they were in stock. You might have missed that, so what we wanted to do is take that code that Liz wrote and run it on that same product pick of the week that I showed, which is our, I've got it hooked up, we'll show it in the overhead. But that is the board that's inside of here. That is the TFT Feather with ESP32S2. It has Wi-Fi, so it can be on your network and listening for tweets. It has a screen, so you can check it and see date stamp, when was the last time it checked. It actually checks, I think, every 30 seconds. You can probably tune that a little faster, maybe even. And when it does come in stock, it'll give you a date stamp, time stamp of when it was in stock, in case you hear the alarm, run over and check and see, how much time you have. But most likely the thing you're going to do is just go and quickly try to buy one. So that second thing I said is an alarm. So what I wanted to do is take one of these. You can see I've got the box here because I started prototyping it. One of these warning lights that we have, these have a pretty loud piezo buzzer in the bottom with a little volume control, and it has an array of LEDs that make it look like a spinning siren. So you can see and hear this from pretty far away, and what we want to do is trigger that whenever we get one of those tweets. So let me jump over to the workbench and I'll show you where the prototype of this is at, as well as we'll build out what is going to be more of my finished version of that. So let me head over here, and I'm going to pull up the Discord on my phone just so I can see if anyone has questions. So let's zoom out a bunch. I'll focus there. And I'm going to be doing some soldering, and I wanted to be able to see what I was doing better, so I brought my microscope, a little stereo microscope in here. Oh, hold on, let me mess with these lights. On. Okay, that is down. Discord, where'd you go? You are. That update there. Okay, so I'm going to move this microscope out of the way for a second. And let's get that out of the way. So you can see here I've got some little circuit diagrams that I did up in fritzing to sort of explain what's going on here. The idea here, I'm going to use a proto feather to put this little transistor circuit on here. And then the TFT feather will be actually stacked on top of that so we can still see the display. The basic circuit here is that I'm using pin A1 on the feather as the trigger for I'm forgetting my words here, but it's essentially flipping the switch of the transistor. So we'll send a signal out to, what is it, drain on this one. It's a tip 120. That will then allow the transistor to pass through the 5 volts from the USB on the feather to the, and I'm just showing an LED here, but that's actually going to be this alarm. And then I have a resistor in the path there of the control, just for protection. And then we're running the ground is what actually gets synced over there when that flips. So here's what that circuit looks like on a breadboard. And I need to move some things here to give myself, I have kind of a short USB cable there. All right, hold on, I'm going to unplug that, give myself a little longer cable so we can zoom in there. There we go, this is a convenient extension. Okay, so what you'll see here is this is going to connect up to my Wi-Fi, hopefully. And I have right now, just for testing, woo, that's loud, sorry. I have the alarm going off, and then it'll wait for me to press the boot button there, which is, I'm not using it as a boot button in this case. That button that's labeled boot can be used as just a regular user button. Ah, so it's going off right now. Okay, so why is it going off? It's saying let me turn the volume down on that. The Model B 2 gig RAM is in stock at Adafruit. 1 unit's in stock. Yeah, I think that's wrong. I think we need to maybe adjust it so when it says 1, we exclude that because I think there's 0 right now. So I can press this button again. It'll stop the alarm until this updates again if it checks and says that that's in stock. So I'll go ahead and unplug that for now, and we'll talk about that circuit there and how I'm transferring that over. So just get a little pointer here. You can see I'm going from ground on the feather to ground on the transistor. I'm going from the USB power 5 volt to this power rail, and that's going directly to the LED or the alarm. And then the ground of the alarm is what's passing through the middle leg of the transistor. And then the first leg on the transistor goes through the resistor to the control pin. I'm using pin A1. You could use any digital GPIO pin. So that's the basic circuit of this. Let's jump over to the workstation for a second, take a look at the code, and then we'll come back here and build out the nicer version so that we can get away from the cardboard box prototype here and get into a nice little 3D printed sort of shell that I built for it and a neat little circuit. So let me jump back here, and what I'll do is actually bring up the device and plug it in and pull the current code off of there. So let me grab that. And I've turned off the alarm, or turned the volume all the way down on it. I think we may still hear it a little bit. I'm not sure that that cuts it off entirely. Let me grab a USB cable. By the way, something else I should check is in stock is I love these USB-C to USB-A right angle cables that we have with a little woven cord. These are great for keeping your USB sort of discreet, and I'll show you how I'm using it in the case design here. But right now, I'll go ahead and plug that in. And by the way, these, I think, have the reversible USB-A. So you'll see, I think I've got that right. I think this is the really thin one that has contacts on both sides. So even though that's not the original USB-A spec, it'll fit in either way, which means none of the guessing that you usually have to do with getting that flipped properly. Let's see if I got it. Yeah, okay, so that's gonna start up here. And I'll wait a second for it to fire up the, you can see here, just fire it up the alarm. Pause that, it might come back on. So let's go over to the code for this. So I'll close that existing code. Let's open up, wrong code. That's the cursor control one. Don't save. It's not showing up, hold on. Okay, this is pretty close to it, but I don't think my CircuitPython device was showing up there for some reason. Maybe it is the cable, my beloved cable. Let me plug that in on a different one. So you can see here in the code, this is all Liz's code, by the way, with a couple of small additions that I made. But this is using, you can see here, alarm pin, I've picked A1, and button is the board dot button, which is that boot button. Then it's using the secrets.py file to grab some of my credentials, and that includes Wi-Fi credentials, your Twitter bearer token, and this is all in the Party Parrot Twitter guide that Liz wrote, and I'll be doing a guide here that grabs most of that and then just shows a couple of the additions. But it tells you how to go and set up with the free developer API inside of Twitter to get that bearer token and other API information you need. Then it sets up the radio to go connect to your SSID and password that are in the secrets file. Gets the time using Adafruit I/O time server, so that way we can compare, only check the past hour when we get an update. Turn that off again. Some setup for the text display there. You can see I tried making that bigger. I did a scale 2 to it, but I was losing some of the text. There was just a little more text than we could fit on there. So it is hard to see. Just depends on how young your eyes are. Mine are struggling with that. Then during the main loop of this, first thing I do is just check the button to see if it's been pressed. If it is, I turn off the alarm pin or set that pin to low, and that just stops the alarm from ringing, but it'll start back up again the next time it finds there is some stock. And then this is what's checked every 30 seconds. Again, I'm not sure if you'll run into any issues if you ping more frequently than that. Maybe, maybe not. And then the rest of this is extracting some of the info both from our URL for the Twitter address or Twitter account for RPyLocator, grabbing the timestamp information so it can do a comparison. And then here's where it checks to see if we're within that past hour. It'll tell you that you've got the Raspberry Pi in stock. Otherwise, it just leaves the previous text up there. And then if it's no new stock, it'll just leave this no new stock in the last hour up there. So now let's go ahead and take a look at making this a little more of a finished project. So what I did was actually started from that cardboard prototype. Let me jump back over there. And I actually kind of liked the general form factor of this. It just didn't need to be that tall because I'm not hiding that much underneath the bottom of it. But I had an idea of putting the feather in the front here so it could sit here kind of like this. So I went with that basic idea. Set that over here. And I designed this little board that I 3D printed. Let me switch my camera out. There we go. Go, try to focus that. So yeah, it's a little hard to see because it's black. But this is the same sort of basic idea. I have the 3 M4 holes there for the bottom of the alarm that can just pop into there. And we've got some little washers that we can, or nuts that we can use to screw onto there. I have a hole here, and that's just for passing wires through. So I want to be able to pass the wires from the bottom of the alarm under here, as well as the USB cable through there. My feather is going to sit on top, and then the circuit of the proto board is actually going to sit on bottom. So this I designed to fit these little header pins like this. And so now we have, and I did it in yellow just because that way we can see it, otherwise you wouldn't be able to see what's going on there. And then we'll be able to just plop the feather, let me take it out of this breadboard, which is a little difficult. Be able to plop the feather right on top there. We could also add a top here, a protective top if we want, but the general idea of the case is just to fit that on like that and fit our alarm on like here. And that gives us some little feet. You could put some rubber bumpers on there if you want. Enough clearance for all of the bottom of the board there. And I've also got, if we start taking a look at the proto board, I've also added a little terminal block here so that I can screw in the wires from the alarm without it being soldered directly. So it just makes it a little easier to do assembly and disassembly. So I've put together some of this, but some of it we got to finish off here. So we'll take a look at what we've got. So so far what I've put together are my transistor is here. It is not yet run to ground. It has not yet been run from the center to the terminal block for the ground of the alarm. I've not yet run power from the terminal block to USB. And I have done this, which is I actually just ran this resistor from the control pin to the first pin on the transistor. So that's there, but we've just got a couple of these little wiring things to do. So this is, I like working with these proto boards because it's not quite as involved as doing a printed circuit board, but it's kind of the same idea. You're running some direct wires that'll get the job done. So I'm gonna, first thing I'll do here is how about we'll run our power to the USB. And you can see here I've made a little white mark and put a black line on it for the negative side of the terminal, just because I'm flipping it upside down. It's really easy to get that confused there. So let me get a soldering iron warmed up here. And I will grab take a look at my Discord on the phone. Okay, so I've got just a little piece of silicone wire. I'm going to run that through the top of the board, and then on the bottom side I'll solder it to the same pin that I need on the terminal block. And that's because these Permaproto, or these Proto feather wings, none of these pins are connected except for there's a strip of ground and a strip of 3-volt power over here. So you got to make those connections yourself. So what I'll do here is set that through, cut it to length, poke it into the top side there for the 5-volt, then flip it over and do both, solder both sides of it there. So this is going to USB power. Let me see which one that is. It's the 4th one? No, 3rd one. This is not printed with anything, so I actually have to take a look at this feather to make sure. So 1, 2, 3. Yeah, the 3rd one is the USB. Yeah, so about right there. I'll cut this. I brought my good snips, by the way. Remember my troubles previously with the really dead ones I have in here. Again, this is the silicone wire that I really like because you can get away with just using your thumbnail to strip it. It's just faster than needing a wire stripper most of the time. So, oops. Let's take that. Hey, Adam. This is Woo-ha 007. Nice to see you over there in the Discord. Okay, so this will go from USB right there to, and I just want to avoid any stray wires. Okay, so that's the little connection I'll make there. And like I mentioned, what I want to do is actually see if I can have a little angle on my microscope, a little stereo dissection microscope, and I should be able to still show you what I'm working on and see it myself. So that's angled a little there. There we go. Looks pretty good. Let me find it and focus. Where's the focus? This is backwards from how I usually use it. Aha, okay. Let's see if everything will reach. Okay. So that's actually, I should have stripped that one a little longer, and let's see if I can fix that. I actually need that to touch the same pad that the terminal is plugged into, and I forgot to do that. Let me grab a little tool. There we go. I think that did it. Let me just tip that down so I can see. Yeah, so that is now soldered to the same pad as the positive side on my terminal block. And then this runs to the USB pin, USB power pin over here. I highly recommend these if you can get them. These are old optical stereo dissection microscopes, and boy, they're great. This one I think is a 10x eyepiece on it. Yeah, I also have some 20s, and boy, it's great. You know, it's, well, digital ones are nice, optical ones are nicer in my experience. Nice and clear. This one was Olympus, I think. It says on here somewhere. Yeah, Olympus. Okay, so that means that we now have power, and I will now go from the ground here to the center pin of the transistor. And just because that's just to kind of keep things consistent with my circuit here, I'm going to use a piece of blue wire there, just so that we don't get confused. That's not actually ground, that's it's going to the center of the transistor. Okay, so this time I've made this a little longer, and that means I can go through the hole and then up to our terminal block. And same thing on the other side. Slightly eyeballing this, but it's okay. This doesn't have to be super flush. Spin that around. Okay, so this will go from negative, where'd my tweezers go? I really want to be using those. I set them down somewhere great, I'm sure. Here they are. No, that's not tweezers. There's some tweezers. It's a little easier for you to see when I use the tweezers than my hands for this. So go here. And whoop, just like that. Okay, let's flip that around. Okay, so here I'm gonna, you can see I bent one of the legs of that transistor forward, and now I can have that wire meet it. Voila! And then, let's get those tweezers again. This wire here, I need to just bridge to the negative side of this terminal block. Okay. Let's have a look at that. Looks nice. Now we'll run a ground from the third leg of the transistor to the ground on the board. That is this right here. And there's a nice convenient sort of whole row of connected grounds on the proto, so you don't have to go to just one particular spot. I'd originally done this, the one I showed yesterday, I had done this with 12-volt power supply, mostly because I think I was thinking of some of our other alarms which only run on 12. This one will go from 3 volts to 12, so there's no reason to get complicated, and you can just use the transistor to pull the USB 5 volt. Works pretty well. Not enough current on the 3 volt, I think, from what I found. So I have got that in the wrong one. Here we go. Okay, we'll flip that over. And the ground side is actually just directly to a pad. That's a little easier than the bridging, so I'll do that first. Just to keep that stable. Okay, I'll trim that in a second, but first, boy, I wish I had a little more cable on this soldering iron. Here we go. So for this one, let me bend this over to meet like that. Great, so now we can trim off a little excess there, and we're just about ready to test this out. Gotta keep an eye on some of the bits you clip off so they don't land right back on the board and short things, especially little stranded wires. A little scary. All right. Not a bad idea to make sure. Okay, so just checking my diagram here one more time. I've got the USB going to the positive terminal. I've got the ground going to the third terminal, or third leg, middle leg going to negative, and the resistor going to pin A1. Looks good. One thing I'd like to do is just a continuity check on my ground and power on the board, just to make sure there aren't any surprises when I plug things in. So I'll just take a multimeter here, continuity mode, and we can just go from this ground sorry, these are in the way. Yay, no continuity there. So at least we aren't going to instantly blow up the feather when we plug that in. Okay, so I can get that out of the way there. We can take the alarm and just to test this before I assemble it all into the case, since these are on screw terminals, I don't have to worry about threading it through and then soldering it. That was kind of my biggest reason there. So I'm going to attach the ground wire of the alarm to this negative terminal. Let me get a super tiny flathead. Is that one good? Maybe. That one's not tiny enough. Let me see, I think I have a even smaller one. Question mark. I know where I have some others if this doesn't work. Let me just try this one first. Nope. Okay, hold on one second. I'm gonna go grab a little set of flathead screwdrivers from a drawer marked small screwdrivers. This one will work. These are good to pick up when you see them at yard sales. So here's a, oh no, wait, these are Phillips. Those are not flathead. Uh-oh. Where did I thought I had a set of those. This is funny. Do I not have a screwdriver small enough for this at the ready? What about this one? Yeah, that'll do it. This old Weeha set to the rescue. That'll work. Yes, okay. So let's plug that into there. Sometimes, by the way, you got to unscrew these all the way before you can put the wire in them, just based on how the thing traps the wire. That might have been the case here. Good. I will have to do this all a second time when I put this into the case. But I feel like it's good luck to test it before assembly. You're tempting fate otherwise. Oh wait, are these? Is that in there? Seems like it's in there. Who thought that this would be the hard part, getting these screw terminals to work? Which way is this going? Sometimes these go backwards. Let's see. Okay, yeah, so that draws this upward. So I think I missed the little, it's like a little elevator. There we go. Okay. So take our feather, plug that in. And so that's the basic idea of being able to get the TFT still visible, but add components to it. It could be any feather wing. In this case, it's just this proto feather wing. And now for power. Uh-oh, that's a bad sign. It went to the REPL. Let's reset that. Let me try it without it plugged into the board to see if I got something wrong on the circuit there. So let's... No peripherals, see if it gets there. Otherwise, we can go check the code. Yeah, okay, so that's a sign. What did I get wrong? That is... That looks right. Let me try it again. Why is it unhappy? Okay, let's see. I'm going to take one side of the alarm off of there first, just to make sure it's not a current thing. Okay, you're off. It's not happy about something. It's like it's trying to get to the REPL. Right? Yeah, I don't think it's going anywhere past that. All right. Let's compare this to my circuit. Did I... Okay, that is definitely the USB 5 volt to positive. It is definitely ground to ground. It's definitely the negative side of the terminal block to the center of the transistor, and then resistor to, let's see, pin A1 is 1, 2, 3, 4, 5, 6 over. 1, 2, 3, 4, 5, 6 over. All right. That all looks good. Let me look at it under the microscope to make sure I don't have some short. That does tend to be one likely issue. Okay. That looks good on the power side. Transistor legs are fine. I see no shorts. Flip it over. No stray wires. That's to USB. That's to ground. That's to A1. All right, that's a mysterious mystery. I'm going to plug this back into the breadboard version, which should be the same circuit. Just to remove all possibility. Let's go like this. Let's give that USB power. By the way, sorry, YouTube chat, I cannot see you right now from my phone, just the Discord. Oh, and it looks like maybe my Discord isn't connecting. Let's see. Let me try to reconnect that. Yeah, so that looks like it booted fine on the breadboard. Let's see if it comes up. I missed the first screen, but it should come up with the next one. Yeah, it looks like I'm on the Discord there. Yes, that's connected. Let me just check the Discord over here real quick. All right. Sure the transistor is the right way around, Todd asks. Let me get over here real quick. I will double check that, but I think it is. Wagon Loads asks over in YouTube, what are you making today? I'm making a Raspberry Pi locator alert. So this checks rpilocator.com's tweets, and when Adafruit has an RPi in stock, it will run this alarm. So let me go double check what Todd just mentioned, which is, do I have the right transistor orientation here? So transistor orientation on my breadboard, you can see, goes, darn it. No, yes, no. I did it wrong on the breadboard. Thank you. I went, no, I'm okay. Darn. Yeah, that is fine. So yeah, ground is the third leg. Alarm ground is the center leg, and control is the first one. This is a tip 120, right? Yes. All right, let's see if I can find anything with continuity. By the way, I think my phone connected to a different Wi-Fi. Yep, sure did. It's trying to get Wi-Fi from this clock over here. That's why I couldn't see Discord on the phone. There we go. Okay, now I see Todd typing again. So grab this and see if there's any continuity issues. So USB power, that's good. Center leg, that's good. Ground, that's good. I think, yeah, Todd was asking if I've got any other miswiring. I can see some of the silk screen on the top of this. So that does say USB for my power there. That one is ground for the ground. I think. Let me grab that feather. Yeah, the fourth one over. 1, 2, 3, 4 is the ground. Yeah. What could it be? Jim Hendrickson gave me the blue meanie let out smoke icon. I am perplexed. All right, I'm going to just try it again and just see if we run into random luck. But that is funny that it's, I swear, the same circuit. And on the breadboard, and it's running. And I'm not shorting anything on the bottom of the board there, so that's good. Let's go ahead and give that power. Huh. Yeah, I don't know what it's thinking. You know what, let's bring it over to the computer just to see if there's any error message there that we can see. I'm seeming unlikely, but let's just check. You might be able to see it a little closer up on this camera too. Let's bring it over here. And I'll do that view of the world. How about? And let me grab that USB cable. So this one's known good, at least from a power standpoint. Although this one didn't show me data earlier. Let's see, I'm guessing we won't be able to get into the REPL on it. Crashed hard. Yeah, that's not good. There must be I must be running into a short or something on this board. Because I think it's still happily running when it's not plugged into there. Yeah. So, okay, I've got some short here. I must. Let's go and take a look back under the microscope. Hope you don't mind the troubleshooting journey we're going on here today. We'll give it a couple more minutes of attempts and then I'll work on that offline. What I may do too, just so you can see it, is put the case and everything together the way it should work once this is solved. Okay. Let me look. I'm a little suspicious maybe I've got a short right at the transistor that's hidden. No. It doesn't look like it. I don't think you can test the transistor with simple continuity check, I'm guessing. Yeah. And let me just check. This is a same transistor I've got over here. I think I got them out of the same batch. Yep, same one. And nothing bad there. Sorry, I'll pull this out of here. I'm just going to hold that. Yeah, this is the ground. A0, A1. Nothing. Looks clean as can be. No little wires shorting it there. All right, I think I will bail. Let's assemble it. Just maybe we'll get lucky. Maybe if we put the whole thing together, it'll suddenly solve whatever gremlin is there. But I want to show you how my intended assembly is. So this will pop in under here. And I can just set that on the workbench and press down. It'll get the headers flush with that. And then we'll take, actually before we put the feather on, I'm going to feed these wires through this little hole here. And I'll also feed my USB cable like that. Zoom out just a little. And then I can just fit these three M4 screws like so. I don't need them actually because the fit's pretty solid, but we do have, if you get one of these alarms, it comes with 3 nuts for the M4 screws. I'm just going to leave that be. And then this I could trim because we really only need to go that far. And then this will plug into our USB. And then the feather plugs right in here. And I'm just using the strength of the header pins to hold those, but I did add some M2.5 holes there that line up with the feather and the feather wing, so you could secure those on if you had the need. And then remember I was mentioning earlier, this little USB cable gives you a nice discrete plug there without it kind of hanging off the side or anything. Pretend that's plugged in there. And I'll go ahead and plug this in just for kicks. Let's see if it somehow decides to work. Wouldn't that be nice? No, I think I'm shorting some. I should stop plugging this thing in. I'm going to blow up the USB on that feather. But that is the basic design of it there. You saw it working on the breadboard earlier and in my little demo. So I got to clean that board up, and then I'll post that design and the 3D model over in a Learn guide for this. So Steve Robillard says, would love an update on what the problem was. I would too. Wagon Load says, anything shorting against the bottom of the transistor. Yeah, Steve Robillard, troubleshooting often teaches more than the happy path or pre-baking the whole thing like a turkey on a cooking show. Yeah, I didn't want to just build it last night and show it to you here today because that's not that interesting. So, but I think I will, I'll end this now, and when I do figure out what it was, I will show you next week. So if you tune in, or I'll post a little thing on Instagram and Twitter so that you can see it in action. But thank you for your help with some of the troubleshooting ideas, and if you have others, I'll be over in the chat, so come on over to our Discord. You can see right there, that's the Discord. Do we have a bad transistor? Maybe. Confirming resistor value. Anything under the header, only connection is the transistor base to emitter to ground through the resistor. Pull tran, replace it. That may be it. That'll be fun. I actually may just clip the leads and solder a new transistor once I confirm it to the top. Actually, maybe grab that one out of the breadboard. Maybe I should have tested that first, but oh well. Thanks everyone for stopping by. I will be back on Tuesday with a product pick of the week. And we, I believe, have a deep dive with Tim tomorrow, so tune in for that. And if you're wondering when the shows are, you can head over to our Discord and do a little bot command !showtimes, and that'll let you know when shows are. And yeah, Foamy Guy Tim should be on at 5 o'clock Eastern on Friday, and possibly on Saturday at 11. So yeah, Wagon Lewis says lift the transistor, see if the short goes away. These are good ideas. I will go play with that. Thank you everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next time. Bye-bye.